Tēnā koutou katoa, ko Emma Carroll toku ingoa, he aunuku aho I Waipapa Taumato Rau. So, as Simon introduced me, I'm Emma Carroll. I'm from Auckland University, Waipapa Taumato Rau. And today I'm going to be talking about a collaborative project looking at the migratory connections of humpback whales. Humpback whales, like other large baleen whales, are migratory, so they move from wintering grounds north of New Zealand, and they head south to feeding grounds around Antarctica. So New Zealand has this amazing position where we're sandwiched between wintering grounds and feeding grounds, and as a result, we actually have several whale highways in our waters. So the northernmost is around the Kermadec, or Rangitahua, and we have whales that travel south past the Kermadec. We also have whales that head north through the Cook Strait, but today we're going to be talking about the humpback whales that stop off in Fiordland on their way south to Antarctica. And so the primary question is, which wintering ground do the whales that we see around Fiordland come from? And so this project is an ongoing collaboration between Murihiku Papatipu Runanga, Department of Conservation and the Auckland University. And I have to highlight that this was actually initiated by Rochelle Constantine, who's a professor that I work a lot with. But it's a kind of large ongoing project. And the fieldwork's done on the Southern Winds vessel, which travels quite widely throughout Fiordland for this fieldwork. And what you can see is on the left is a map here, and so this is the 2017 track of the Southern Winds, and you can see that the boat goes in and out of the fjords, and each black dot here is a humpback whale. And so the humpback whales can be encountered quite frequently during that kind of southern migration period, kind of October, November, December. And so to understand those migratory connections, we have been using two approaches, the first of which is photo identification. So if you take a photo of a humpback whale's tail fluke, so the underneath of their tail, what you can see is these different patterns of coloration and also the nicks and notches along the trailing edge. And some of these are really quite distinctive and allow us to identify individuals. The other way we investigate this is by collecting small tissue samples from free-ranging whales. And so we use a remote biopsy system that fires a small dart. The tip of the dart hits the skin of the whale and pulls out a plug of tissue about the size of your fingernail. And this is where I get really excited, because that little bit of tissue can tell you so much about the private lives of these whales. They can tell you who they are, who they're related to, what they've been eating using microchemical markers. If you look at epigenetic markers, which are like the formatting on the book of DNA, we can tell you how old that whale is. And if you're lucky enough to get a little bit of fat or blubber along with that bit of skin, we can even give them a pregnancy test and tell you if that whale is pregnant. Or if it's a male, is he able to mate and reproduce? So that little bit of tissue and blubber can tell us a huge amount about those whales. And so, just as a quick summary of how the surveys have gone, between 2017 and 2023, the Fiordland surveys have collected 98 tissue samples, and we've generated DNA profiles so that we can individually identify each whale. And we've compared the DNA profiles of the Fiordland whales with about 3,000 whales from across the Australian and Oceania wintering grounds. If we consider the photo identification data, we've got about 27 photo IDs collected, so from prior to when these surveys started in 2005 through to 2020. And those photo IDs have been compared with an international database on a website called happywhale.com. And if you haven't seen it before, I would recommend going and having a look. It's a really neat website that if you've got any photos of whales, you can then look at and figure out where those whales have been around the world. Now, jumping straight into the results, matches between Fiordland and East Australia have actually been found, which is really exciting. So we've got one DNA profile match. So this whale was first sampled, a skin sample was collected in 2002 in Queensland, and then it was resampled in Fiordland in 2020. So that's 18 years apart, but we know it's the same animal. Now, there's also been photo ID matches from East Australia to Fiordland. So there's 3 of them. We don't have the specific details of those, but they've come through that happy whale matches. Now, again, genetically, if we look at the population or the samples from Fiordland, I'm not going to go into the details, but essentially when we look at the wintering ground these animals are most closely associated with, 85% are Australian and about 15% are most closely linked to New Caledonia. So what we can say is that the southern whales, or those whales that are visiting Fiordland, are East Australians and New Caledonians. Now, this is really consistent. So what this graph is showing is these are whales that were tagged in Eden in New South Wales, and the blue lines and red lines are their tracks. And so what you can see is that some of these whales, they went from Eden across and they've visited around the Southland. Now, the other thing to realise is the red dots, that's where we think they might be feeding. And so what you can see is there's some red dots close to Fiordland. And when we've gone out there, you can actually see them doing pink poo. And pink is generally krill. So they are feeding, at least some of them are feeding and then pooing. And so that's probably what's happening. They're probably stopping off for a snack on their way south. And so I'm going to segue here to another kind of thing that the University of Auckland does, the New Zealand Cetacean Tissue Archive. So this is an archive of national significance, and it's held at the University of Auckland, but it's for the whole of the country. And essentially what happens is whenever there's a stranded whale or dolphin, if mana whenua agree, the Department of Conservation will take a small tissue sample, and then send it to us at the University of Auckland to curate an archive. And so one example is actually this photo in the background, which is West Auckland, which is where I grew up, and there was a sperm whale stranding there a few years ago. And so sperm whales are a taonga species, and they're a very important species. So this was quite an unusual and special event. This archive has been going for over 30 years and has nearly 3,000 specimens from all across the country. It's the second largest cetacean tissue archive in the world, and it has some specimens from species that have actually never been seen alive before. And essentially it's one of New Zealand's longest running citizen science initiatives, because people have to report the sightings of these animals for the samples to be collected. And what's quite special about what we do is it's a way of giving a life after death to these animals that wash ashore on our beaches. From that really small bit of tissue, we can tell you what species it is, we can tell you who it's related to, is it male or female. And then using different kinds of technologies, like we would with the humpback whale tissue sample, we can look at what and where they're feeding, reproductive rates, their age, stress, and even their culture. And so carefully curated collaborations and technological advances allow us to continue asking questions. So for example, it's taken about 30 years, but we now have about 50 samples from one of the rarer beaked whale species. Now, beaked whales are basically deep-diving sausages that will grow up to 15 metres. And this particular species is a Cuvier's beaked whale. They can dive over 3,000 metres for over an hour. But they're so hard to study, it's taken 30 years to get a good sample size for New Zealand to understand how they fit into the global context. And so, as another example of what we do, in 2011, this whale here, Nihonori, which is her blessed name, washed up, and we identified her as a Trews-beaked whale. And what you can see here is Tohunga Tora Ramari Stewart working with Doc to preserve her skeleton, because it was the first time the species had washed up in New Zealand. But when we started to look at Nihonori's genetics in the context of the species globally, we realised that the southern hemisphere form of the species was quite different to the northern hemisphere, and in fact represented a different species. And so in 2021 we described Ramari's beaked whale, Mesoplodon eu, which was a new species to science. And so that's just an indication of what we can do with just little bits of tissue from these animals that wash ashore and leave their secrets with us in that form of that bit of tissue. And so I'm not going to take too much more time, But I'd love to point out that Fiordland is home to more whales than just humpbacks. And this is an Arno's-beaked whale. They get up to about 10 metres. They're also deep diving sausages, but they're so cool. We don't know much about them. And so the other thing about Fiordland is we have very few records in our archive from this part of the country. And so what would be really interesting to do is think about dedicated surveys for marine mammals, for cetaceans, given you have humpback whales, but also these deep diving, enigmatic and elusive species. What else could we learn by having dedicated surveys around Fiordland? It'd be really exciting to find out. And I'd just like to thank mana whenua, especially Murihiku Papatipa Runanga, Department of Conservation, especially the crew of the Southern Winds, Mike Ogle, Chloe Korn and Richard Kinsey, Debbie Steele and Fang Fei Tam for help with lab work.